That's why I did that. So every time we do one of these reactions, we need to make sure three things. We need to make sure that we have the identities of the reactants and products correct. So if we're supposed to be making carbon monoxide, then the formula needs to be for carbon monoxide. What's the formula for carbon monoxide? CO. You can't do carbon dioxide if you're supposed to be writing down carbon monoxide. Then the relative amount of each atom needs to be correct. So if you're counting, I've got one hydrogen, I need to have one hydrogen. You need to count each individual atom. And then lastly, we haven't talked about this yet, the state of matter for each reactant and product. So we just describe them. Here in this example, calcium's a solid. See, lowercase s represents solid. If it's a liquid, we write an L. If it's a gas, we write a G. And then this isn't really a state of matter, but it's just a really good description. It tells people that it's dissolved. AQ stands for aqueous. So when something's dissolved, we're not saying it's in a new state of matter. We're just saying it's mixed together with water. It's dissolved in water. Let's take a second and try to balance this one. You and me, we're balancing this one, okay? All right. How many? All right. So we're going to use the T-table again. We've got the reactants versus products. What are the elements in this one? Calcium, hydrogen, and oxygen. How many calciums are on the reactants, and then how many on the products? 1 and 1. So right now the calciums are already balanced. Now let's go, the hydrogens. Over here we have plus, how many are here? 2 more. So this is actually 4 on the product side. What would you multiply the reactant side by then? 2. So we need to have a coefficient, that's what you call those numbers in the front, a coefficient of 2, so it doubles the amount of hydrogen. That also impacts the oxygen there, doesn't it, though? So how much oxygen is here now? There was 1, but now we've doubled it, so there's 2. No, it just means there's 2 waters. She said, does that change it from water to something else? No, that means there's just 2 waters in there. All right. If it was going to change formulas like H2O2, that's drastically different. This actually is a violation of something we're going to talk about in a second, where you can't change the subscript. If you change the subscript, it's no longer water. It's now something completely different. So by putting a coefficient in front, you're just saying there's twice as much water. And all of the other subscripts could be 1s. I don't write the 1s in, so they're just blank in there. And now it's balanced. You have 4 hydrogens. 2 plus 2 is 4 hydrogens. 2 oxygens. You already had 2 oxygens, so it's already balanced. That's the focus of this chapter. It's just balancing equations. This is a reaction we're going to do next class. We're going to burn magnesium. It's one of the 6 stations. Burning magnesium is really dangerous for 2 reasons. Number 1, the smoke that he is allowing to go in his face is not good for your lungs. So we're going to do it in the fume hood to protect ourselves. Number 2, when you burn magnesium, it produces a very bright white light, and it'll actually burn your eyes, kind of like staring at the sun for 5 minutes straight, but in about a half a second. So instead, we're going to give you plate glass so you can look through the plate glass. It'll filter out the harmful rays, and you can still look at it, but it won't be damaging to your eyes. When we're doing these reactions, we are going to have to go back to the periodic table and think about balancing charges. So I'm going to go to the periodic table. What's the charge of magnesium? Plus 2. What's the charge of oxygen? Minus 2. So does magnesium oxide already balance there? But the equation is not balanced. Now I need to come back. I see that there's 2 oxygens to start with. So what do I need to do to this side? Multiply it by 2. But now there's 2 magnesiums. I need to come back over here, multiply that by 2. That's going to be a very common theme in our future, is predicting the products, using charges to think about those products. And because these products are plus 2 and minus 2, that's why we can't change the subscripts. They're based on the charges. Yes, JK.
So even though we did it like we balanced the chemistry like last chapter, we have to do it number
Yes, we have to use the charges first, and then we'll balance the equation. So you'll hear me we kind of use the same thing in this chapter as we do next chapter. I'll say, first it's the charges, then it's balance the reaction, and then lastly we'll talk about the states of matter. But we're not going to talk about states of matter really this chapter, but predicting states of matter is something we talk about in the next chapter. Yes, B.